Hello YouTube, we're back on the air. How you doing? Let's go. So I'm going to go online so I can put this on my blog. Alright, so let me do that. What is it? Alrighty, so I want to get onto Sage Math, blah blah blah, that. Alright, did you make a new worksheet yet? Because you're so good at this. Alright, so my new worksheet will be, well, what do you think it's going to be? Go on, give me a new worksheet. Alright, 6.2. And 6.2, what did they call this? Did they call it propositions? Operations of propositions? Alright, I'm going to call it, alright, propositions. Something that's true or false. Propositions. Anything that's true or false. That you can work with like in the truth table, right? All right, your name and the date. What are we at? 2013.0205, the 5th? Yeah, okay. All right, so question number 1. We're on page 98. Everyone with me? Almost. Almost, maybe? What's the negation of I do? I don't. That was tough. 2. What is the conjunction of I did my homework, I went to see a movie? What does conjunction mean? And or not. And. So what are you saying? I did my homework and I went to see the movie. Okay. Now, how about this one? Number 3. Rephrase in English the negation of neither here nor there. What's the negation of neither here nor there? Now, that's where I'm going to start. What does it mean, neither here nor there? Can you write that as a simple, logical statement with ands, ors, and nots? Not nor, not neither. Neither here nor there. Not, okay, I'm going to say not here or not there. Isn't that what it means? Neither here nor there means not here or not there. Okay. Now they want the negation of that. Now, didn't we just talk about the negation of an or? How do you negate an or? We just talked about that a minute ago. It's the conjunction of the negations of the disjuncts, right? So instead of not H, well, you forgot already. Wait, hang on. The negation of a conjunction is the negation of a conjunction is the disjunction of the conjuncts, right? Well, they have something a little different here. They have a disjunction. Do the same idea, though. What do you think? H anded with. How am I going to write an and? What's the and symbol on here? Okay, that's an and symbol. Shift 7? Oh, shift 6, you mean? Shift 7. That? No. That's the shift 7 is not an and. That's an and. That's as close to an and as we're going to get. So H and what? T, right? Right? Because we said that the negation of a conjunction is the disjunction of the negations of the conjuncts, but do it backwards. What we wanted was the negation of a disjunction. So you get the conjunction of the negation of the disjuncts. So I'm going to negate not H and get H. I'm going to negate not T and get T, and I'm going to flip the or and make it an and. That's it. So the negation of neither here nor there is, it's here and it's there. Amazing. Now, nobody said it's true or false. It's just the negation. All right, number 4. Restate the proposition, I can't read or write. What do you think they mean by that? I can't read or write. Do they mean I can't read and I can write in English? Or are they saying I can't read or I can't write? Is that what they're saying? Is that the same thing like we just did a minute ago? Neither here nor there. They really mean it's not here or it's not there. So restate the proposition I can't read or write as a Boolean expression in terms of P's and Q's, where P is I can read and Q is I can write, and then write the negation. Isn't this the same question? Yeah. Number 4. I want the negation, okay, of I can read or I can, wait, let's see. I can read, they're calling that P, right? Or I can write, that's Q. Now, is that what they started with? Before the negation. Is this what they started with? What I wrote is, I can read or I can write. Is that what they want? No, they want I can't read or I can't write, right? So it's basically the same question, just different symbols. There's a not here and a not here, and there's an or in between. Is that the same question? So they want you to negate that. So negate it. What do you get? Just the same way. What do you get? P ended with Q. That's what they meant. All right, fine. That's fine. Can you write a truth table for P or not Q? Aha. Let's write a truth table for P or not Q. Let's let Sage do it. We already did one on the board, right? That's just easy. All right, so what I want to do is make a truth table for P ORed with not Q. I want a truth table for that. Is there a way I can make Sage generate a truth table with all cases like this? Something like this. Well, how many columns do you need to start? How many variables do you have? 2. So start with a P column and a Q column. What other column do you need? A not Q column, and then the whole thing, right? All right, so that's what I'm going to say. I'm going to say I need a column for P, I need a column for Q, I need a column for not Q, and I need a column for everything, for the whole thing. Okay? So I need a column for that, a column for that, a column for that, and there, that. I want I want Sage to do that for me. How am I going to do that? Well, let's see. How about let's just get a heading. Print, quote, P. How do I space things out into columns? Remember, we've done this.
Oh, we have the backslash tab.
Backslash who? T for tab, okay. And then Q slash T. Then not Q slash T. Then P or Q. All right. Is that what you want for your headings? Nope, I messed up. It's a not Q here, right? Is that your heading? That's your heading, right? Sort of like we made headings here to start. When we started, we made the headings first, right? All right, do the same thing here. Now, I wanted to generate all the values of P and Q starting with 0, 0, 0, 1, 0, 1, right? That sort of counting in binary type of thing. Doesn't this sound like a loop? When P is 0, Q becomes 0 or 1. When P is 1, Q becomes 0, 1. Isn't this a nested loop, a loop inside of a loop? Have we done that? A loop inside of a loop. All right, so for, let's see, for, wait, where am I? I want to be here. For P in range 2, print P. Is that what you want? Remember what range 2 does. It counts 2 integers starting with 0. Okay. Now look what I'm going to do. I'm going to do something sneaky. Inside that loop, for Q in range 2, get rid of the print here, put it here. Print P, comma, slash, in quotes, slash T, comma, Q. Is that what you want? Do you see what it's doing? When P is 0, Q becomes 0 or 1. Then when we're done with all the Q's, P becomes 1, and then the Q's start up again, 0 or 1. Isn't this the truth table we wanted so far? Right? Okay. Now how am I going to make it print not Q? I want a not Q column. So how about comma, quote, tab, quote, comma. Can I just do this, not Q? Yeah. But did I want true, false, or did I want 1, 0, 1, 0? How do I turn that into numbers? Is that what you wanted? You could do true, false, whatever it is, but I wanted the numbers instead because I want to show that this really has to do with binary. All right, now how am I going to do the and? Well, just do it. I want to do P and, oh, I need a comma, yeah. Comma, quote, tab, quote, comma. P anded with not, we don't talk about that stuff. Q. Is that what you wanted? Well, yeah, some of them are zeros, some of them are not. How about we interfy the whole thing? What'd I do? How did he get over there? Get over here. Is that what you wanted? Remember, or, is that what I wanted? Or? Yeah. Or is only false if disjunction is only false if both disjuncts are false. These two are not, wait, these two are not, whoa, something wrong here. Oh, because it's not an and. It's, what is it? It's an or. Whoops, sorry, it's an or. All right. A disjunction is false if we have a false here and a false here. Look, we have a false and a true, so that's true. We have a false and a false, so that's false. We have a true and a true, so that's true. And we have a true or false, and that's true. Or is only false when you have false, false as inputs. These are the input columns. P and not Q are the input columns. And we're doing an or. Did you get that? All right, who's stuck? Oh. That means you're stuck, I guess, yeah? Okay, what? We're using nested for loops to generate all combinations of pieces of data. Yeah, but still, it should give you something. Well, yeah, now you need to not. Oh, so I messed up everything. Who didn't get this output? Forget the error that. You good? So it's really easy to generate truth tables in binary. That's what we're doing. Amazing. Sage realizes that 0 means false. 1 means true. In binary. All right, everybody still stuck? We're good? You got it? We didn't get the same output I had, though. Because you have a but they said the new voice. All right, anyone else still stuck? We good? Are you still stuck? You getting there? Mario, what's yours? What'd you say? You got it? You got it? Okay, good. Yes, exactly. Okay. Alrighty. Okay, so we did it up to the first truth table, which is number 5, right? All right, let's leave it at that. We're about out of time. So, bye-bye, YouTube.